Picture this. It's 2 in the morning. A developer's hands are hovering over a split-screen terminal.
Setting the scene. I like it.
Right. So on the left side of the screen, you have the underlying architecture of this massive AI model built by Google.
Mm-hmm.
And then on the right side, you've got the complex reasoning chains from a rival model built by Anthropic.
Two totally different, totally proprietary ecosystems.
Exactly. And this developer, acting entirely alone, with no contract, no legal team, and absolutely no permission, is actively fusing the weights and parameters of these two models together.
Which is just wild to even think about.
They hit enter, a progress bar fills up, and suddenly the terminal lights up with outputs from something entirely new.
Mm-hmm.
It's a highly capable hybrid that neither tech giant ever designed, authorized, or even intended to exist.
Yeah, and it represents a total breakdown of the traditional software development lifecycle.
How so?
Well, for years, we've watched these massive corporations pour billions of dollars into building these pristine, isolated AI systems. And the assumption was always that the creator of the model retained ultimate control over how it functioned, right?
Right.
You build it, you own it. Exactly. But the reality on the ground today is that those barriers have just completely disintegrated.
And that is exactly why we're here. Welcome to the Deep Dive. Today, we are exploring a massive, permanent shift in the power dynamics of the AI industry.
It really is permanent, yeah.
We are looking at developer logs, the latest pricing breakdowns from what LLM, brand new research out of MIT, and even some international diplomatic briefs. Because right now, there is a fierce tug-of-war happening.
A really expensive tug-of-war.
For sure. On one side, massive corporations are locking their absolute best AI behind incredibly expensive, highly restricted velvet ropes. On the other side, an open-source rebellion is literally ripping those frontier models apart.
Just tearing them down to the studs.
Yeah, remixing their core components and giving the resulting hybrids away for free.
And this past week, that rebellion produced a huge watershed moment. The Hugging Face community dropped the model called Darwin 31B Opus.
Darwin 31B Opus?
Yep. The community is actually referring to it as the dawn of the Frankenstein era of AI.
Mm-hmm.
And, I mean, looking at the underlying architecture, it's really hard to argue.
Happening under the hood of Darwin 31B Opus.
It's quite the mashup.
Because my first instinct is to think about physical engineering, right? You can't just take the hyper-efficient engine out of a top-tier Porsche and drop it into the rugged chassis of a Ford.
Right, yeah.
The mounts don't line up, the transmission doesn't fit, the computer systems speak entirely different languages. How do you take a Google model and an Anthropic model and just shove them together?
See, the mechanical analogy falls apart there, precisely because we aren't dealing with physical constraints. We are dealing with mathematical matrices.
Okay, fair.
The community utilized the Darwin V6 engine. It's this specialized tool designed specifically to map and blend the mathematical weights of different neural networks.
Fascinating.
Yeah, so they took Google's open weight model, which is Gemma 431B, and they literally merged it with Keach AI's Claude Opus Distill.
Wait. I need to pause on that second half. Claude Opus isn't an open source model.
No, not at all.
It's heavily guarded by Anthropic. How on earth did the community get their hands on a distilled version of it to merge with Google's architecture?
Well, they didn't steal the actual code or the original weights from Anthropic. Distillation is this really fascinating workaround.
How does that work?
Essentially, a smaller open source model, in this case, the one built by Keach AI, is trained to act as a student. The developers feed massive amounts of complex prompts into the official Claude Opus API.
Oh, I see.
Yeah, they generate millions of incredibly high-quality step-by-step reasoning outputs. Then they use that massive data set of Claude's answers to train their smaller student model.
So the smaller model learns to mimic the master's reasoning patterns without actually possessing the master's, 2 trillion parameter brain?
Exactly. It's learning the behavior without having the raw horsepower.
It's sort of like a master chef writing a highly optimized cheat sheet for a line cook.
That's a great way to put it.
The line cook doesn't have 40 years of culinary experience, but if they follow the cheat sheet perfectly, they can reproduce the signature dish. So they took this line cook version of Claude, which has great reasoning, and they mathematically merged it with Gemma 4.
Yes, and the mechanism for merging is actually closer to cross-braiding plants than swapping car parts.
Cross-braiding plants?
Yeah. If two neural networks share a vaguely similar structural lineage, like, say, a transformer architecture with comparable layer depth, you can mathematically average their weight matrices.
That sounds complicated.
It is, but basically you take the numerical values of Gemma's neural connections, blend them with the distilled Claude's connections, and you create a single matrix that exhibits traits of both parents. And remember, Gemma 4 is a 31 billion parameter model renowned for running incredibly efficiently on consumer-grade hardware. Claude is renowned for methodical, hallucination-free reasoning.
So the resulting Frankenstein model gives you Claude-level logic running at Gemma-level efficiency.
Exactly. You get the best of both worlds.
I mean, I see the appeal for the developers, but if I'm a product manager at Anthropic and I see my billion-dollar intellectual property being distilled and stitched onto a competitor's architecture on a public forum, I'm terrified.
Oh, absolutely. It's a nightmare for them.
Does this mean corporate product roadmaps and copyright protections are functionally obsolete now?
I wouldn't say obsolete, but it permanently alters who holds the leverage. The original creators no longer dictate the capabilities or the safety guardrails of their products once they hit the open market.
Because everyone is just tearing them apart anyway.
Right. The open weight strategy, which originally just meant here is our model for you to download, had inadvertently created this massive intercompatible Lego set.
And the momentum there is clearly accelerating.
Hugely. Hugging Face's State of Open Source Spring 2026 report, which was published just a few days ago, noted that in a single 7-day sprint this April, 8 major frontier models were shipped.
8 in 1 week.
Yes, and 5 of those 8 were open weights.
That is wild. I mean, the community is tearing down the walls because the corporations are building them higher than ever before.
That's the tug of war.
Exactly, because if we look at the other end of the rope in this tug of war, we have Anthropic's direct counterforce to this entire open source movement, their new flagship model, Claude Mythos.
The big one.
Yeah, this is the exact opposite of a lightweight, remixed Frankenstein model. Mythos is a 10 trillion parameter behemoth.
It's massive. It is a scale of computing that requires an amount of electricity and silicon that most sovereign nations do not possess.
Really?
Oh yeah. Running a 10 trillion parameter model requires a massive, synchronized cluster of top-tier GPUs just to generate a single word of output. The computational overhead is staggering.
And because of that scale, Anthropic has gated it entirely. There is no open access. There is no public API at all.
It's totally locked down.
Under a program they are calling Project Glasswing, access to Claude Mythos is restricted to just 50 organizations globally.
Just 50.
And when I read the What LLM pricing breakdown, I actually assumed it was a typo.
I know exactly what you're going to say.
They are charging $25 per million input tokens and $125 per million output tokens.
It's just unprecedented. That pricing structure represents a massive philosophical fracture in the industry. We are now seeing an extreme divergence in how intelligence is distributed.
Here is what I am struggling to understand, though. In the exact same week that Anthropic announced a $125 price tag, Zippu AI in China released GLM 5.1 under an MIT license, making it completely 100% free. You have models spanning from literally $0 to $125 per million tokens hitting the market simultaneously. So, is that hyper-premium price tag genuinely justified by the intelligence of a 10 trillion parameter model? Or is it just a deliberate velvet rope designed to keep the ecosystem exclusive?
Well, the compute cost is a very real physical constraint, but pricing it at $125 per million output tokens absolutely functions as a filter.
To keep the riffraff out.
Basically. By setting the barrier to entry that high, Anthropic ensures that only major enterprise clients, defense contractors, and massive financial institutions are interacting with Mythos.
Oh, I see.
It isolates the model from the chaotic remixing culture of the open source community we just talked about. They are protecting their asset by making it too expensive to distill or play with.
Wait, I'm stuck on the math here. If massive corporate models require gigawatts of power and billion-dollar budgets to function, how is the open source community pulling off things like Darwin 31B?
That's the million-dollar question.
Right, because mashing up a 31 billion parameter model still requires significant computational muscle. A decentralized group of developers on Discord doesn't have a massive compute budget. What is the catalyst making this affordable for the little guy?
The catalyst arrived on April 9th. Hidden in a technical paper published by researchers at MIT, they introduced a technique called Compress SM.
Okay, the SSM stands for state space models, right?
Exactly.
I know the industry has been trying to pivot towards state space models because they handle massive contexts better than traditional transformers, but they are notoriously difficult to train.
Very difficult, yeah.
What exactly did MIT figure out here?
To understand the breakthrough, we have to look at how state space models process information compared to traditional transformers.
Okay.
A transformer looks at every single previous word in a document simultaneously to generate the next word. If the document gets twice as long, the compute power required quadruples.
Oh, so it gets exponentially harder.
Right, it scales quadratically, which is why long context transformer models become impossibly expensive. An SSM, on the other hand, maintains a compressed state of the context.
Like a running summary.
Yes.
Yeah.
As a new word comes in, it updates the state, so it scales linearly. The problem is that finding the optimal mathematical parameters for that continuous state during the initial training phase is computationally brutal.
So MIT found a way to shortcut that brutal training phase.
They did. They applied control theory directly to the neural network while it is learning.
Control theory.
Yeah, it's a mathematical framework usually used in dynamic physical systems. Think about keeping an airplane stable in turbulent air by constantly adjusting the flaps based on sensor feedback.
Oh, okay.
The MIT researchers applied this dynamic feedback loop to the parameter weights during the actual training.
I'm picturing a pair of mathematical calipers.
Calipers, okay.
Yeah, imagine this massive, sprawling network of data trying to organize itself, and these algorithmic calipers just clamp down on it dynamically. If a parameter isn't affecting the stability of the output, the algorithm prunes it mid-flight.
That's actually a perfect way to visualize it.
It's squeezing out all the empty space and redundant connections while the model is actively processing data.
That visual captures the mechanism perfectly. It's akin to zipping a file, but instead of compressing the data after the work is finished, you are compressing the mathematical operations during the training process itself.
Which saves a ton of compute.
A massive amount.
Wow.
The control theory algorithm dynamically identifies which computational pathways are redundant and shuts them down in real time.
And the results from the paper are just wild. This technique cuts the training compute, FLOPs, by up to 50% across language models, audio generation, and robotics.
And all without sacrificing the accuracy of the final output.
Which brings us back to my question about the decentralized developers. When you cut the computational overhead of training an architecture by 50%, you fundamentally alter the economics of AI development.
You do.
But let me push back on that, though. 50% of $1 billion pre-training run is still $500 million.
True.
A community of open source remixers cannot afford $500 million any more than they can afford $1 billion. Does CompressSM actually democratize AI, or does it just help the massive corporations save money on their energy bills?
Well, it actually does both, but the impact is really asymmetrical, and it heavily favors the open source community.
How so?
You are absolutely correct that training a frontier model from scratch remains completely out of reach for small teams. But remember, the developers building Darwin 31B Opus are not training from scratch.
Right, they're mashing things up.
Exactly. They're taking pre-existing open-weight models and fine-tuning, merging, and distilling them. Those secondary processes require a fraction of the compute power.
Oh, I see where you're going.
Right. If a community fine-tuning run previously required, say, $50,000 of rented server time, a 50% reduction drops that barrier to $25,000.
Which is a lot more achievable.
Hugely. In the realm of crowd-funded developer communities, that is literally the difference between a project dying on a message board and a highly capable Frankenstein model being deployed to the world.
The cost barriers are falling so fast that the digital math is finally favoring the little guy.
Yes, it is.
It proves that creating these powerful mashups isn't just a stunt, it's intensely practical. But, it's easy to think of this open source rebellion as purely digital, just code floating in the cloud, infinitely remixable, completely borderless.
It certainly feels that way sometimes.
Yeah, like a developer in Portland can collaborate with a founder in São Paulo, pull code from Paris, merge it with a model from Silicon Valley, and deploy it to a user in Lagos in an afternoon.
The software absolutely operates in a frictionless, borderless reality. But, and this is a big do, but those millions of cheap training cycles still require physical silicon. This digital abundance relies entirely on incredibly fragile physical infrastructure. Fiber optic cables, massive cooling systems, and highly specialized microchips.
And right now, the physical world is throwing up massive roadblocks. You cannot sustain this AI arms race without physical supply chains, and the geopolitical board is actively contracting.
It really is.
Just to keep things objective and purely look at the board as it is, if we look at the macro data from this week, the contrast to the borderless digital ecosystem is jarring.
It's a totally different picture. The most immediate choke point is the escalation in global trade tariffs. China just raised tariffs on U.S. goods from 84% up to 125%.
Wow.
Yeah, matching the previous rate set during the Trump administration.
125% tariff wall on physical goods. When you think about the global supply chain required to manufacture a single top-tier GPU, I mean, the rare earth metals, the lithography machines, the silicon wafers moving across multiple international borders before ever reaching a data center, that kind of economic friction is immense.
It inherently drives up the baseline cost of compute. If the hardware becomes drastically more expensive to manufacture and ship, those costs are passed directly down to the developers renting server time.
The trickle-down effect.
Exactly. And the friction extends far beyond economic policy into hard diplomacy and physical geography. Direct U.S.-Iran negotiations opened this week in Islamabad, Pakistan.
And a central issue on the table there is access to the Strait of Hormuz, right?
Yes, which is critical.
The Strait of Hormuz is one of the most vital logistical arteries on the planet. If shipping lanes in the Middle East or the Indo-Pacific face disruption, the timeline for delivering the hardware necessary to run models like Claude Mythos or merge models like Darwin 31B breaks down entirely.
We actually saw a related geographic maneuver this week when the UK officially froze its transfer of the Chagos Islands.
Oh, right. They paused the sovereignty transfer specifically due to opposition from the United States.
Which all comes down to the Diego Garcia military base located on that archipelago.
Because it is a strategically vital asset for projecting power and securing logistics routes across the Indian Ocean. Every piece of critical physical territory, every shipping lane that carries the components of the AI revolution is being heavily guarded or actively contested.
It's all connected. And in the background of all this physical world chaos, the basic maintenance of the digital ecosystem just quietly presses on.
True.
Like OpenAI patched a critical vulnerability in the NPM Axios package ecosystem this week, completing the fix in under 48 hours.
It's a perfect encapsulation of the reality developers are facing. While nations are throwing up 125% tariff walls and diplomats are negotiating over military bases to secure shipping lanes, developers are just trying to keep the foundational code libraries from breaking.
Exactly.
It is a defining tension. You have infinite digital ambition being built on top of incredibly fragile, highly contested physical supply chains. The software wants to be infinitely remixable, but the hardware is bound by geography and tariffs.
Eventually, those two realities will force a reconciliation.
You think so?
Oh, definitely. If physical hardware costs spike due to supply chain friction, the open source community will be forced to rely even more heavily on software-side efficiencies like MIT's Compress-SM just to keep their projects viable.
And that reconciliation directly affects you, listening right now. You might think, I'm not a machine learning engineer. I'm not stitching AI models together at 2 a.m. Why does the underlying architecture of a neural network matter to my daily work?
But it does.
It absolutely matters because the tools you are going to rely on tomorrow, whether you are drafting a complex legal brief, analyzing a massive data set for your company, or writing code, are likely not going to be pristine, singular corporate products.
They won't be. They will be highly capable, aggressively remixed hybrids. They will run cheaply on compressed architectures, leveraging techniques like control theory to operate on your local devices.
Yeah.
And they will be built by decentralized communities who are innovating at a speed that traditional corporate structures are really struggling to match.
We are stepping completely out of the old binary world, where you bought a software license from one company and got exactly what they designed. We are deep into the muddy open waters now. It is chaotic, it is constantly evolving, and it is incredibly powerful.
Which leaves us with a critical forward-looking question to consider.
What's that?
Well, if community remixing continues to outpace corporate engineering, and the cost of training and fine-tuning keeps getting slashed by research like MIT's Compress-M,
Yeah.
will the next trillion-dollar AI breakthrough emerge from behind the velvet rope of a megacorporation's walled garden? Or will it come from a decentralized group of developers on a forum who just figured out the most efficient way to stitch the giants together?
Oh, wow. That is exactly the thought to leave on. Thank you for joining us on this deep dive. The next time you open up a new AI tool and marvel at how smart it seems, take a second to imagine what might be running under the hood. It just might be a hybrid intelligence built by someone in the middle of the night who didn't ask anyone for permission. Until next time.